So video number 3, and I goofed up. I guess I started working problem 11 before I hit the record button. So it's kind of all written out for me already. I'll just kind of talk our way through it. We still have to find f plus g of x, f minus g of x, f times g of x, f divided by g of x, and we have to find the domain for each one. So in order to add these two functions together, I had to find a common denominator of x minus 4, x plus 8. So I had to multiply that guy by x plus 8. So that gave me 9x squared plus 72x. I had to multiply that guy by x minus 4, so that's 7x minus 28. And when I put my like terms together, that gave me 9x squared plus 79x minus 28 over x minus 4, x plus 8. And x can't be 4, x can't be negative 8. So think about a number line. Don't include negative 8, don't include 4, but everything else. So we're going to say negative infinity to negative 8, union with negative 8 to 4, union with 4 to infinity. So the minus one is remarkably similar. Still have to find a common denominator. Still have to multiply this guy by x plus 8. Still have to multiply this guy by x minus 4. But I've said this many times, I like to tuck that negative sign up close to the 7 so I don't drop or forget about it. So you've got 9x squared plus 72x minus 7x plus 28. Put your like terms together, and now it's 9x squared plus 65x plus 28 over x minus 4, x plus 8. And the domain is the same because it's the same as adding. All right, now let's do multiplying. So there's f of x times, there's g of x. So remember, when you find a common denominator, when you multiply, you don't have to find a common denominator. So you just multiply. So 9x times 7 is 63x, and then same thing on bottom. And so same domain we've talked about for each problem. All right, now let's do the division one. So there's f of x divided by g of x. I decided to write it sideways because a lot of times people get stuck with it, like they struggle with it written this way. So I wrote it sideways, which remember means you have to flip. And so now it's multiplying. You do not have to find a common denominator. And so you have 9x, x plus 8 over 7x minus 4. Now, sometimes people think that that means negative 8 would not be a restricted value, but negative 8 would be a restricted value, because if I had you plug negative 8 in right here, you would end up with a 0 on the bottom of that fraction. So you wouldn't have even been able to get to this guy because you would have had a 0 on the bottom right there. So the domain is exactly the same. All right, let's flip it over and look at 12. Okay, so now let's talk about square roots. So remember, square roots have restricted values because you can only have 0 and positive numbers inside the radical. Just as a little Algebra 1 review, those are called whole numbers. Your whole numbers are 0, 1, 2, 3, 4, 5. So you can only have a whole number. Well, no, you can have a fraction. What am I saying? But it's got to start with 0. So to add them is the square root of x minus 2 plus the square root of 2 minus x. Can't do anything with that. So that's the answer to adding them. But the domain, so x minus 2 has to be greater than or equal to 0. So x has got to be greater than or equal to 2. And 2 minus x has to be greater than or equal to 0. So you minus your 2, negative x greater than negative 2, divide by negative, flip your inequality. So your domain has to be greater than or equal to 2 and less than or equal to 2. So think about that for a second. What numbers are greater than or equal to 2 and less than or equal to 2? I'll even draw a picture. Greater than or equal to 2 and less than or equal to 2. Well, that's just 2. All right, the subtraction one is very similar, and the domain is still going to be 2. All right, what happens when we multiply them together? Well, when we multiply them together, you get the square root of x minus 2 times 2 minus x. There's no real reason to FOIL that out. And so the domain of that guy is still going to be 2. And then this one is the really interesting one. You have the square root of x minus 2 over the square root of 2 minus x. So again, that's got to be greater than or equal to 2. See, this guy is greater than or equal to 2. This guy, why is there no bar underneath it? Because it's in the denominator. So it's got like a double domain issue. It has a square root in the denominator. So what number would be greater than or equal to 2 or less than 2? Nothing. So the domain is the empty set for that one. I like that one. That's a good bit of a thinker. All right, so we're going to finish up video number 3.